Good morning, everybody. So, in this lecture, we will discuss some of the problems related to the applications of Bernoulli's equation. So, the applications of Bernoulli's equation. The first one is Venturi meter, and in Venturi meter, we focus on the problems. You all know that Venturi meter equation is QA is equal to CD into A1 A2 root 2G divided by A1 square minus A2 square into root H. If the Venturi meter is fixed in a horizontal pipe, then H is equal to, it is P1 by gamma minus P2 by gamma, as datum head does not come into picture if the Venturi meter is fixed in a horizontal pipeline. So P1 is the pressure at inlet, P2 is the pressure at the throat. So knowing the pressures at inlet and throat, we can find out H. But this how we will find out is using the differential manometer. So in the differential manometer, using the differential manometer, if X is the deflection in the manometer, then H is equal to X into Sm by S minus 1, where Sm is the specific gravity of manometric fluid and S is the specific gravity of flowing fluid. So knowing Sm and S, we can and X, we can find out H. So otherwise, A1 is the area of the venturi meter at the inlet. A2 is the area at the throat. So if the diameters are given, we can calculate straight away the entire parameter. CD of the venturi meter, generally it is 0.98. So H we have to calculate by using like this, so that we can estimate the discharge. The purpose of venturi meter is to measure discharge. So now let us take straight away the problems. Even before going to the problems, one more point also I wish to specify. If suppose the venturi meter is fixed, the venturi meter is fixed in an inclined pipeline, or in other words, the venturi meter is in the what you call it as the inclined position. When the venturi meter is in the inclined position, H is equal to, it is P1 by gamma plus Z1 minus P2 by gamma plus Z2. So this is the way which we should calculate, where this P1 P by gamma plus Z is called as piezometric head. So here it is not the pressure head that is matters, it's the piezometric head that matters. So depending upon the problem that is given, we have to solve the things. So now let us take straight away a problem on venturi meter. A horizontal venturi meter. A horizontal venturi meter with inlet and throat. With inlet and throat diameters 30 centimeters and 15 centimeters respectively, is used to measure the flow of water. The readings of differential manometer connected to the inlet connected to the inlet and throat is 20 centimeters of mercury. Determine rate of flow. CD is equal to 0.98. So straight away first write the equation. Q is equal to CD into A1 A2 root 2G divided by square root of A1 square minus A2 square into root H. This is the first thing that you should do. Then now he has given first thing is horizontal. Then what is H I mentioned? So we have given basically the deflection in the manometer X is equal to some 20 centimeters of mercury. So therefore H is equal to X into Sm by S minus 1, which is equal to zero point 0.2 into Sm is 13.6 divided by flowing water is 1 minus 1. So which reflects to finally it comes around 250, basically 252 centimeters, basically, which is coming 2 centimeters of water. So therefore now if we go for it is Q is equal to CD into A1 A2 root 2G divided by square root of A1 square minus A2 square into root H. So CD is equal to, which is given is 0.98 into A1 A2 root 2G divided by square root of A1 square A2 square. Separately we can calculate A1 is equal to pi by 4 into D1 square, which is equal to pi by 4 into zero point 0.3 whole square, and A2 is equal to pi by 4 into D2 square. So pi by 4 into 0.15 whole square. So A1 A2 G is equal to 9.81. Uh, So knowing these things are, so this substituting all this actually, we will get again a point. The root H means root of, basically in terms of meters, if I put it is 2.52. So finally if you calculate this, you are going to get basically almost we will get actually it is 125 into 756 into 10 to the power of minus 3 meter cube per second. Basically the discharge Q is equal to. So this is one problem. The second problem we can take it up. I will take it up is a horizontal venturi meter, a horizontal venturi meter with inlet diameter, with inlet diameter 20 centimeters. and throat diameter, and throat diameter 10 centimeters is used to measure the flow of oil of specific gravity 0.8. Discharge Q is equal to 60 liters per second. Find the reading of oil mercury differential manometer. Differential manometer. Take CD is equal to 0.98. So now here also the way how we start is D1 is known. D1 is 20 centimeters, zero point 0.2 meters. T2 is equal to 10 centimeters, zero point 0.1 meter. So A1 is equal to pi by 4 into D1 square. A2 is equal to pi by 4 into D2 square. Calculate these two. If you calculate these two, then for example, A1 will be, if you take it 314.16 into 10 to the power of minus 4 meters square, and A2 is equal to, you take it, it is 78.54 into 10 to the power of minus 4 meters square. Then afterwards, CD is equal to 0.98. Then actually he has given Q is equal to 60 liters per second, which is equal to 60 into 10 to the power of minus 3 meter cube per second. So by knowing this, now let us put a equation. Q is equal to CD into A1 A2 root 2G divided by square root of A1 square minus A2 square into root H. So Q is equal to already 60 into 10 to the power of minus 3 is equal to 0.98 into A1 A2 means A1 is 314.16 into 10 to the power of minus 4 into 78.54 into 10 to the power of minus 4 into root of 2 into 9.81 divided by A1 square root of actually 31.14.16 into 10 to the power of minus 4 whole square minus 314 minus 78.54 into 10 to the power of minus 4 whole square into all this into basically root of h. So if you calculate all these things, you are going to get h is equal to, which you will get from this all, basically root h is equal to, you will get first, then from that h is equal to 2.89 meters of oil. So this is what which we get it. Then actually we want the deflection, we want the deflection in manometer. Therefore, H is equal to x into Sm by S minus 1. So H is equal to 2.89 is equal to x into Sm is 13.6, S is oil is zero point 0.8 minus 1. Therefore, x is equal to, finally, what we have to calculate is, if you calculate, it is 0.1812 meters or 18.12 centimeter. So this is, but all of them are of the same model. What we are doing is only calculation of using the same equation again we are calculating it. So I will take into another problem actually. A horizontal venturimeter. A horizontal venturimeter with inlet diameter with inlet diameter 20 centimeters and throat diameter 10 centimeters is used to measure the flow of water. The pressure at the inlet the pressure at the inlet is 17.658 Newton per centimeter square, and the vacuum pressure at the throat is 30 centimeters of mercury. Find the discharge. Find the discharge of water through venturimeter. Take CD is equal to 0.98. So the novelty in this problem is if you take here also inlet, outlet, inlet through diameters are given, right? Instead of giving deflection or instead of giving discharge. So in this problem he has given the pressure at the inlet is given, and the pressure at the throat is, it is vacuum pressure at the throat. Please note this. So problems, three varieties. In the first problem we calculated, they have given the A1, A2, and they have given the deflection in the manometer. So used the equation and found the discharge. In the second problem, they have given actually A1 diameter at the inlet and throat. So A1, A2 are known. Then second, discharge is given. They asked to find out deflection in the manometer, right? That is the third problem is, instead of giving either manometer deflection or instead of asking it, they have given pressure difference in terms of pressure at the inlet and pressure at the throat. So now let us go into how to calculate it. So straight away I will, I need not again tell, D1 is equal to 20 centimeters, right? D2 is equal to 10 centimeters. Please be cautious about the units. If you are taking in 0.2 meters, this is 0.1 meter. So A1, A2 calculated pi by 4 into D1 square, pi by 4 into D2 square. Calculate these two. If you calculate these two, 314, previous example only, into 10 to the power of minus 4 meter square. This is 78.74 into 10 to the power of 4 meter square. So this is over first A1, A2. Then let us go for calculation of H. So calculation of H, we want to calculate. How to calculate? What is P1 by gamma first? Pressure head at the inlet. Pressure head at the inlet, how we will get first pressure he has given, it is how much actually, the pressure that is given is 17.658 Newton per centimeter square, right? We want to convert into Newton per meter square. If we want to convert into Newton per meter square, 10 to the power of 4, so that all this will become Newton per meter square. P1 by gamma. Gamma is how much actually, it is 9810 Newton per meter cube. So finally how much we are getting actually, it is, we are going to get 18 meters of water. This is first thing, 18 meters of water. Then what is P2 by gamma? P2 means throat. P2 by gamma, how to, they have mentioned it as 30 centimeters of Hg, right? 30 centimeters of Hg vacuum. Vacuum means minus. So this minus is because of the pressure is vacuum pressure. This is the first thing. Then now what is H is equal to H 30 centimeters of Hg means minus basically 0.30 meters of Hg. And if I want to convert into water, basically if it is I want to convert into 13.6, so it will be minus 4.08 meters of water. So that both P1 and P2, if you take here it is, here it is, both are in terms of water. Then H is equal to P1 by gamma minus P2 by gamma. So if I take like this, P1 is 18, right? Minus of minus 4.08. So it is total together, it is appearing it as 22.08 meters of water. So this is over. Now actually what you need to do, directly use the equation Q is equal to CD, right, into A1 A2 root 2G by square root of A1 square minus A2 square into root H, right? CD is 0.98. So middle one you calculate, then root H is already it is mentioned, into root H is 22.08. If you calculate all the things, you are going to get actually 0.165 meter cube per second. This is the answer. So here I stop actually the venturimeter problems, especially with respect to the horizontal venturimeter. Now I take one or two problems in the next class, the inclined venturimeter fixed in the inclined pipeline, and then go to the next problems. So in this particular lecture, we have solved three problems on the venturimeter. In the first problem, we try to solve for discharge by knowing the diameter at the inlet, diameter at the throat, CD value, and also basically the value of the differential manometer reading. That is first. Second problem is discharge is given, but the differential manometer reading is asked. The third problem is given, instead of giving deflection manometer, they mention what is the pressure at the inlet and the pressure at the throat. But the significance of the problem is the pressure at the throat is given in terms of vacuum pressure. When it is given in terms of vacuum pressure, that too 30 centimeters of mercury he has given. So that is basically, first thing is 30 centimeters of mercury. Vacuum means minus 30 centimeters of mercury. So minus 0.3 meters of mercury, because on pressure head at the inlet is in terms of water, so convert the pressure head at the throat also in terms of water. So converting to that point minus 0.30 into specific way, gravity of mercury 13.6. So like that, that is one novelty. Otherwise the problems are all based on one single equation, right? Now next class we will see some of the problems in when the venturimeter is kept in an inclined pipeline. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.